This video goes through the solution for question 31 part 2 on page 491 in Text and Tests 4. So the first thing that I notice about this equation is that I've got different bases in these two terms here. So I'd really rather have the same base throughout, so I want to start by adjusting that. And this rule, of course, is that I can change from log to the base b of x to log to the base a of x or log to the base a of b. Okay, so I'm going to choose the log to the base x of 4 to change. And I'm going to choose to change this to a base 4 because the other term with the log has a base 4 already. So on the top of my fraction, I'll have log to the base 4 of 4. And then on the bottom of the fraction, I'll have log to the base 4 of x. And I'm going to take this now and replace log to the base x4 in my original equation with this fraction. At this point, I can see that I've got log to the base 4 of x several times throughout my equation. I'm going to replace this now with y. So I'm going to rewrite this line as 2y plus 1 equals log to the base 4 over y. Now, of course, bear in mind that this log to the base 4 can be written as 1. Once the base and the number here are the same, the whole log reduces down to a value of 1. So I can rewrite my equation as 2y plus 1 equals 1 over y. Okay, so now I'm going to bring the y up and multiply by the left-hand side. And when I multiply this out, it's going to resolve into a quadratic. As usual, just make sure it's equal to 0 before you begin to factorize and solve. When you factorize this quadratic, you're going to get 2y minus 1 bracket y plus 1 equals to 0, and then we can solve to get two values of y. Don't forget, I'm not quite finished here because it's not y that I'm looking for, it's x that I'm looking for. So I'll take this into account for both my values of y, and then I'll continue on to solve for x. So I'm just going to write each of these in exponential form. And again, don't forget the arrows there can help you remember how to do that. And then I'll evaluate both of these. And of course, 4 to the power of a half can be written as the root of 4. And so that comes out as just 2. And then over here, I'm going to have 4 to the power of minus 1. So x equals 2, a quarter. You might argue that root 4 has two possible solutions, the positive or negative solution of root 4, so plus or minus 2. But if I look back to my original equation, right back here at the beginning, if I had a minus 2, that would be problematic in this position. So I won't take that as an answer. So my two final solutions are x equals 2 and x equals a quarter.